In this video, I'd like to show you how to calculate this integral by using trig substitution. The goal for using trig substitution is to simplify our integral that involves square root. So if you see in your question, you have something like a squared minus x squared or a squared plus x squared. So these things can be challenged to solve directly on its own. So that's why we want to use trig substitution to help us simplify the integral. Let me show you how to do that. So first, let's set as x is going to be equal to sine of theta. And our dx in this case will be the derivative of sine theta, which is cosine theta d theta. And let's transform the integral we have. So now we have 1 over square root of 1 minus sine theta squared times dx, which is equal to cosine theta d theta. So up here we have transformed everything respect to x into things respect to theta. But it doesn't look much easier so far. So let me draw a triangle here to help us understand how we can simplify this integral further. And let's say we have a right triangle here with a theta of this angle. We know our sine theta is going to be equal to x, which can be written as x over 1 as well. And we know sine theta for any right triangle is going to be the opposite side, which is this side, divided by the hypotenuse, which is the longer side. And in our case, we have x over 1. So let's set the opposite side to be x and the longest side to be 1. In this case, you have already correlated your x and theta together in the same triangle. And we know from the rule, the third side of this triangle will be 1 minus x squared, the square root of that. Therefore, we also know the cosine of theta, which is your adjacent side divided by hypotenuse, which is the square root of 1 minus x squared divided by 1. And we can just erase the divided by 1 part. Okay, and based on the right triangle trig identity, we also know that the sine theta squared plus cosine theta squared is going to be equal to 1. Okay, now we have our relationship between x and theta in the same triangle. Let's substitute it back into our original integral. So let's substitute it. We're going to get the integral of 1 over, so the square root of 1 minus sine theta squared. That's just going to give us cosine theta. Based on this rule here, it's going to give us cosine theta. And then we have times cosine theta d theta. So we have successfully transformed something inside of the square root into a much simpler form. And this is how we can simplify the integral. And now we have cosine theta on both the top and bottom, so we can cancel them out. Our integral has become much simpler to be the integral of 1 times d theta. And we know the integral of 1 d theta is just going to be theta. And then because we have an indefinite integral, so it's going to plus c, plus a constant. And to get our final answer, we need to substitute again. So we need to substitute theta back to x in order to get our final solution. So from this original equation here, how we set up the sine x, we already know that theta is going to be arc sine of x. So this is just the inverse of sine operation. So the inverse of a sine operation is called arc sine. So theta is going to be equal to arc sine of x. And don't forget your plus c, so plus your constant. And this is going to be the answer for this question. Now, if you ever see this integral in the back of your book or somewhere, you know how they get to this answer.